In this video, which is the last one for chapter 10 that we are going to be doing, is the matched or paired samples. Now what we're going to be doing is still a student t distribution, but we're going to be doing a student t distribution on the differences. So we're going to have maybe, as an example, we have some students, they take a test, we then give them a prep course, they retake a test. It's the same students, and we test to see if there's any difference between the before and after score. Now, when we do the calculating the differences, it is the after score minus the before score, which is then the difference. So the after minus the before. And then we're back into the chapter 9, and you're like, but how does that happen if we have two things going on? Well, it's because we're going to be doing a hypothesis test on the differences. So after we find the differences, then we still need to find the mean and the standard deviation for the differences. And of course, once we do that, we can go back to chapter 9. I would recommend that you copy and paste the chapter 9 calculator into chapter 10, and we'll talk about what that calculator kind of changes that looks like compared to what it did in chapter 9. A couple of requirements that are required for this kind of matched paired type hypothesis testing is it must be a simple random sample. Sometimes the sizes are small, but make note that if they are small, they have to come from a normal distribution. The population must be a normal distribution, or we have to have a large enough sample size with a large enough grouping of differences so that we can use a student t distribution. Two measurements are drawn, the before and the after. The difference are calculated from the matched or paired samples. And then, of course, the differences form the sample that we do the hypothesis test on. So when we're doing the matched pairs, we have the choice that there is no difference before and after, that the later score was actually lower, so the after treatment was actually lower, so that the differences would be positive. Or the second scores were smaller than the first set, or excuse me, larger than the first set, and so my differences would be negative. So these are the choices. It is that the treatment produced a lower score, or the treatment produced a higher score. In this case, these are my outcomes. Okay, we're again going to be using Excel to do the mean and standard deviation. So that is just the equals. Then you're going to type in AVE for average in Excel. You're going to highlight the differences. And then, of course, you're going to do the standard deviation, which is the standard deviation with the .s because this is a sample. Again, it's going to be an Excel call. The random variable that we are going to be using is a capital X bar sub D. That shows that we are in the mean of the differences, and we're going to be using a t-score. So the distribution is not that. It would have been X bar D is a a t distribution with the degrees of freedom. So our test statistic is the X bar D, and then minus the mu bar D divided by the standard deviation of the differences divided by the square root of the sample size. Now again, this is a t distribution, but we're going to be using X bar, capital X bar sub D. So let's take a look at the first example here. The study was conducted to investigate how effective a new diet was in lowering cholesterol. The results of the randomly selected subjects are shown in the table. The differences have a normal distribution, so that's good. And the subjects' cholesterol levels are lower. Are the subjects' cholesterol levels lower on the average after the diet? We're going to test at a 5% significance level. So what we have is we have the HO. This is, of course, the means. Are they independent? The answer is no. The random variable is capital X bar sub D. So now we're ready to do the null and the alternative hypothesis. Now what we're hoping to show is that the cholesterol levels went down. So my ha then is that I'm expecting the differences, the mu sub D, to be less than 0. Because remember, I take the after treatment, subtract off the before, and I would expect them to be on average a negative number. That means my HO by default is usually the D is equal to 0. So then what kind of is this? Well, this is a left-tailed test. The distribution is a student T's distribution. Student T's distribution. And again, I'm going to talk about the calculator first before I give you the p-value, the critical value, the test statistic, and the decision. So you're going to need something that's going to look like this, where you're going to have the initial value, and then we're going to have the treatment afterwards. So I labeled it x naught as the initial and x1 as being, or x sub 1 as being after the treatment. In this cell, I'm going to do an equal symbol. I'm going to grab this number, which is after treatment. I'm going to subtract off the initial, and then I am going to pull that all the way down. After I hit enter, I'm going to go to the bottom corner where I see it gets become a plus. I'm going to pull it all the way down as needed. Now pay attention in the homework that the initial goes first, the after treatment, or however you want to set this up. The important thing is that you are taking the after treatment and subtracting off the initial. So just pay attention to what is given to you. The order in which you put it in doesn't matter necessarily. It's this that matters. Then I still need to do the mean, and so what I'll do is I will do an equal, and I'll do the AVE average, and then I'm going to grab the cells that have the differences. My standard deviation is stand.dev, stand.s, st.dev.s, and I'm going to go and grab all these as well. And so I'm going to grab my standard deviation. So let's go back up. Oh, and then of course I will have something that looks like this, which is similar to what we had in chapter 9. The only thing is I changed some of the notations. Degrees of freedom is still going to be n minus 1. I did add a mu sub d. We assume it's going to be 0. I have the x sub d. This is copied within wherever my means were. So up above on my previous one is I will copy the cell that has my means, and the same thing with my standard deviation. Here is my t-score of alpha, and my t-score of alpha divided by 2 depends on if I have a two-tail or right tail. These are my critical values. This is my calculated test statistic. And I have a t.dist, I have the t.dist.right, and I have the t.dist.two tails. And these will give me my p-values. Again, I make a decision. So I'm going to go back up here, and I'm going to go and grab my numbers and put them in my calculator. Now, I'm going to take a moment. I know I talk fast. I'm going to take a moment. When I said earlier that I'm grabbing the mean, right, this mu sub d, or this x sub d, this right here should be a cell that is being calculated up here. So I would have grabbed this cell right here for my mean, and the same thing with my standard deviation. So this should be equals to the st.dev.s because it is a sample standard deviation. Okay, so I'm going to go and grab my own spreadsheet. I'm going to put those in, and we're going to give you the p-value. I'm going to give you the critical value. I'm going to give you the test statistic, and then we'll make a decision. So the critical value is going to be my t of alpha, and I ended up, and this is a left tail, so it's appropriate to have a negative 1.8595. So this actually, let's round us up to a 6. Now my test statistic, which is my t-score that's calculated, so I'll do calculated, and it is negative 2.72591. So you can see that the test statistic is on the left side of the critical value. So what is my p-value? Well, my p-value calculated, because this is a left-tail test, is 0.013. So, and we can compare that against my alpha, which is 0.05. So my decision is to reject HO. Why? Because a couple of things is my p-value, which is 0.013, is less than my alpha, 0.05, and my critical value is larger than my test statistic, my t-score that's calculated. And so I would type in or write in something along the lines of there is sufficient evidence to support the claim that the subject's cholesterol levels are lower on average after the diet has been implemented. So something like that. And again, nice short video. We'll see you in class.